not any big issue. Okay, perfect. Okay, thank you, Adaji, for the queries. Okay, so everyone, hello once again. Okay,
Aman, you can
so
start the recording as well.
sure, sir, sure. I'm just about to start. So everyone, yeah, very good morning to all. Uh, I hope my screen is properly shared. My voice is totally audible to you, and we are good to go, right? Yes, good one. Chaliye. So, guys, thanks for joining today's session. I welcome you all again in this world of machine learning. And in the very first session, we got started with artificial intelligence. Then you guys have learned a lot of things about latest technologies. And then in the very last session, we have gone through so many stuff, technical stuff, about machine learning, right? So this is what we have done till now, and now let's start the next part of machine learning, that is supervised machine learning, as you can see. Okay, so let's start with the supervised machine learning. If you do remember, so your face is not visible. Okay, is it now? Is it now? Okay, if not, let me just turn on the camera one more time. I think there's might be a glitch. Just a second. Yeah, just let me know if you now can see me, right? Perfect. Okay, thank you. Okay, guys, let's start. Okay, sir, can you acknowledge just how many and which algorithms are going to be covered in supervised learning? Yes. So I have planned actually a really nice thing for you guys. We'll be actually covering supervised learning in both ways. Like we'll be covering regression as well, and we'll be covering classification as well. In regression, we'll be covering linear regression, multiple regression, decision trees. Okay, some part of your polynomial regression as well. We'll be covering loss function. We'll be covering gradient descent. We'll be covering this is all about me, mostly about the machine learning regression part. And then along with this, we'll be having some understanding about the regularization methods as well that we have discussed in the last class. Then this is for the first half, and second half, and yes, along with the uh, what should I say, the Python file as well. Okay, so we'll be having a discussion on proper regression model as well. Okay, and then in the second half, we'll be having something on classification model. Same with classification, multiple algorithms, and then Python file. Okay, I hope you got the point. Thanks for raising this question, by the way. Thank you, Raj. So, okay, let's go then. So, you guys have will be theoretical only? No, theoretical was practical. Okay, okay. I'll try my best to mainly focus on the mathematics part and the practical part. Okay, though it's a ritual to get start always with the theoretical part, so I'm just following the ritual. Okay, okay. I think it's a good ritual. So, what is supervised learning? Now you are so sure about each and every stuff related to the definitions, especially that what is supervised learning. So, supervised learning is something that comes with the labels. Means first you train it with the examples and then you continue, right? So yeah, okay. This is what you know everything about. Okay. So how basically, the supervised learning looks like. So supervised learning basically looks like this. Regression was a classification. So if you are doing something with a classification, you will always see the final outcome would be like, 0, 1, 0, 1, 0, 1. Okay. 0, 1 means basically categorical. Classification is something categorical. Can we have more than one classes? Oh, sorry, more than two classes? Yes, you can have. Okay. You can have. Okay. So in classification, you can have as many classes as you want. Okay. And in that even you can see here like on the left side the classification output is given 0 1 0 1 0 1, and along with the regression output that is that is somewhat numerical, right? Numerical. Okay. uh, so now you can see like very clearly that how basically the other different features are defining the final predict final prediction, right? So this is the basic and technical difference between the classification and regression. Okay, nice. Okay, so this is what we have like we have discussed in the last class as well. Like, what do we do at first? What do we do? First of all, we actually split the data to train and test. Okay, and then we actually train it, and then we actually measure the outcome. Okay, now we measure the outcome. Okay, when we measure the outcome, we try it with the test data as well. Okay, then we compare. Can you tell me? Can you tell me why we actually compare the accuracy of training and accuracy of testing? Why do we do this? We have discussed in the last class, and we'll have some conversation more. Can you tell me what is the basic reason, everyone, that we are first doing the training, evaluating it, how much it has trained, and then we are testing with the test data, and then again we are evaluating, and then we are comparing. What is the main purpose behind this comparison? Accuracy, like accuracy, you will be getting on training while training the model as well, and while this testing as well. So, what is the reason we are doing these multiple times? Okay, Rudra. Aditya is saying accuracy. Chirag is saying increase the efficiency and easily understand for machine. No, they just if we do not do, then might be face problem of underfitting or overfitting. Okay, so I can see the word make it under this can be required as data only. So how basically you can get whether it is overfit and underfit? How you will evaluate that? I got the point. It's good. Thank you, Parth. It's almost a correct answer. And
बीजों से था
hmm,
आखिर तो कहाँ
no,
दे कम से
Vishwajit,
चलो
this is not the
ज्वाइनिंग
correct
कर
answer.
रिकॉर्ड करवाइए
Tejas,
अगर
yes, it's a correct one. And Rudra, yes, of course. Guys, I hope you got the now second question of mine. The second question is, you guys are some of you guys are saying to test underfit and overfit. How we can do that? How we can test underfit and overfit? What will happen? Then we will say this is overfit. What will happen? Like then we will say it is underfit. Mm-hmm.
मुझसे भी ईमेल चला
Okay, Rudra, nice answer. If the
मैंने तो
model is
जावा
too
की मांगी
simple
थी
and
गेम
just perform best at training.
બધામાં એઆઈ માં જ એપ્લાય કર્યા કરો મેં એનજીઓમાં ગયેલું ને ત્યાં પણ પેલું તેઓ એઆઈ માંથી એપ્લાય કર્યું તો સેમાં ચોરી
And this
કર્યું
is the
તો
reason why I asked this
ઇન્ડિયામાં
question.
ખાલી એકલું જ હતું
So
લાગે છે
now I am getting different
એપ્લાય કરવા
answers.
વાળું वेब डेवलपमेंट कहाँ
Okay.
था? वेब डेवलपमेंट
Though
तो
it's
बस
good,
वही
you
कर
guys
रहा
are having some, technical knowledge of it. But the challenge starts when you actually throw those technical jargons, but actually not in a correct way. So putting the answer in the correct way is really, really important, all of you. Okay. So now let me read the answers one by one. Uh, so Rudra is saying if training accuracy is more than it is overfitting. Tejas is saying if model is too simple and just perform best at training, not best at new data, then it is underfitting. So there are two answers. Rudra is saying if training accuracy is good, then it is overfit. Tejas is saying if training accuracy is good, then it is underfit. What is the reality, guys? What is the reality? Now, okay, now Tejas has changed the answer. Now he's saying if both bad at test and train, then it is overfitting. Okay, this is something, going in different direction now. So, okay, so I can see something from Darshan now. If model performs well in training and testing, but not in real life. Okay. Model does not perform well in testing phase only. Hmm. Okay. Zeal is saying model is underfitting where perform poorly on training. Okay. Ashwin. Okay, Ashwin. Your answer is okay. Okay, okay. So basically, somewhere, the different perspective I can see. Like some are, taking care of the real world scenario, some are taking care of the testing scenario, some are taking care of the training scenario. What is the reality? Okay. So what do we mean by underfitting and overfitting? This is the reason why I raised this question because this slide we have already discussed in the last class. And if we are not, if we are unable to understand this, then we are actually facing problem. Okay. So the thing is, underfitting means when your when your data, when your model is not even learning the basic pattern of training data. This is underfitting. Okay. This is underfitting. When your model is not even getting trained on training data, then it is underfitting. Now, if your model is getting trained on the data that you have provided, get my point. If your model is trained on the data that you have provided, that the examples that you have given with the training, while training, but it is not getting as much accuracy as the training data while testing it. This is overfitting. Okay. Let me give you an example. Just imagine I taught you, I taught you with 100 examples. Okay. Now, first of all, you started failing with those examples. I actually trained you. I have given you the questions. I am giving you the answers. But still, you are only getting 50% accuracy. You are unable to understand the pattern. You are not saying that you are confident enough. You are saying, no, 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 Aman, like we are unable to understand that. This is underfitting. You are not getting trained. You are not learning anything. Okay. But imagine you are getting, 99% in the examples that I'm giving. You are saying, I am 99% confident enough with your examples now. Out of 100, I have solved 99 questions correctly. Now, what is the issue? Now, let me take your test. But when I took your test, again you are achieving 60%. What do we mean by this? It doesn't mean like that you have not learned anything. Yeah, you have learned. I shown you 90, sorry, 100 examples and you have scored 99 in that, right? So it's we cannot say that you have not learned anything. You have learned something. Yeah. You are not underfit. But the problem is you have learned 99 problems so good that you cannot solve any other problem. Right? And don't you think this actually violates the basic fundamental of artificial intelligence? What is the basic fundamental of artificial intelligence? What is the main purpose that I told you when I started artificial intelligence? Can you tell me why we have created artificial intelligence? Automation was already, if you say automation was already happening with the program as well. What was the issue? Flexibility. Yes, Sujal. Thank you for putting this. Flexibility. That it doesn't require the explicit programming. Right? So this is the reason. So when your data, your model is not perform, if when you guys are not performing with the examples that is given by me, it means that you are not learning anything. So means I need to work upon your learning part. Now, when you start getting the number approximately 99% or 98%, whatever the metric is decided, then I will ask you to solve few questions. And on the basis of that, I'll decide whether you are overfit or not. Got my point? So if you are understanding the training data, you you cannot be underfit. You cannot be called underfit. You can only be called overfit, and only when and only if your testing accuracy is not as good as training accuracy. Are you getting my point now? Okay. We can jump to the practical aspect also. That is not a case. But if you are not understanding these basic things, then directly jumping to the technical part just to showcase and just for the sake of the session, it does actually it will not be a good impact. We have to first understand this, the concept behind it. What is actually happening, right? Okay, it's good. It's good. So yeah, you are really aware about the regression and the classification. Is it possible that testing accuracy is higher than training accuracy? Uh, in most of the cases, like in generally, it never happens. Generally, it never happens. Okay. But yeah, like exceptions only proves the rule. Okay. Okay, Parth. Okay. So now let's understand the pipeline. What is the exact pipeline? The exact pipeline is first we collect the data, right? First we collect the data. Okay. Then we split the data into 80-20 ratio, right? Some take 80-20 and some take 80-30. Oh, sorry, 70-30. Am I missing something? Do we do actually something different, or am I going correct? Can we do something else with the data? EDA is okay. EDA is okay. Chalo. Let's ignore EDA now. Data cleaning is okay. Okay. Okay, chalo. Okay, let me. Okay, I know where you're going. Data visualization, clean, recognize, feature engineering. I got your point. Mm, yes, Raj. Thanks for the the clear definition. So yes. So let me give you one hint. What where I'm asking the question. Do you think any more split is required in this data apart from this 80-20? If yes, what is it and why?
Report no?
Actually, I don't
Count.
stratified sampling. What is it? Thank you, Jay. Good one. Yeah, question is right now you can see we are splitting the data to 80-20, right? 80-20. Do you think any more split is required? If yes, it is required or we do such thing, what is it? And why we do that? First of all, what is that split and why we do that? Yeah, it's optional or compulsory, it doesn't matter, but why we do that? Mm, uh, after train, okay, so Raj Patel is saying after train test split and train model then goes to the cross validation techniques to verify accuracy on unseen data. If data is small, then make it learn on ground truth. Okay, okay. Some points are touched, some points are missing. Most the clarity is okay, but the answer can be more clear. By the way, good one, Raj.
विचार वगैरह लगने मांग
So yes for retrain after across validation. Mm, guys, most of the people are saying cross validation. Cross validation is a type of validation. First, tell me what is validation and why it is needed. Okay, Harsh is saying to know how much model is learned from data which has same pattern. Mm, okay, somewhere it might be correct. Because in training phase, we need all type of data and category that we have main data. But why data validation is required? I want that. What is cross validation? Yeah, I'll talk about that. To prevent overfitting. How it will prevent overfitting? Answers over? May I start? Sir. Sir and ma'am. Okay. Chaliye. So the answer is when you actually take the training on some data, and now just imagine you got 60% accuracy or 70% accuracy. Just imagine you are getting 70% accuracy. So the problem is your 80% data is
करना
now
है पास है कि
used.
जरूर
Now your
क्या
model has
कंपनी में
seen
क्या
your
तो क्या
80%
करेगा
data
नीचे कंट्रोल में
already.
देखे
Okay. So now if that model has already seen your 80% of the data, then what do you think? Like if you will train it for second time with the same data, it will even you know uh, even if it is not ready to learn something, as it has already seen the data, it will give you the answers. It's like if I'm giving you some examples to learn, and you are just as you have the answer right now, as you have seen the answer in question, for the next time, even if you have not learned anything, you can just remember the answer and can give you the answer. That's it, right? Right? If you have seen the answer for the first time, if I'm giving you the second time also the same question, then you know the answer, right? And on the basis of that, if I'll evaluate you, then definitely you will perform better. Then what I'll think? Okay, this guy is ready with the train data. Now let's test it. And definitely it will not work with the test data, right? And then this will increase the chance of this will increase the chance of
हाँ बधाने अलग अलग है
overfitting, Darshan. Yeah, thank you, Darshan. Thank you,
एक्सचेंज
Chirag.
करिए
Par.
देगा हाँ
Overfitting.
एक असाइन कर लेते
Because your model is
सेलेक्ट करने
working
का
good with the training data, you think it is working good because it has already seen the data and it is giving you the good number. And now you are ready to open your rest 20% data also. So to avoid this, what do? We do 70 10 20. Some do 80 10 10. some do 60, 20, 20, like up to the people. Okay. Okay. So even 80-20 ratio, you can add 60-20-20 or 70-10-20, 70-20-10, whatever, whatever pattern you want with. I have never seen someone taking less than 60 or 65% of training data. I have never seen that. Okay. So this is why we need validation data. So, okay, so Dhimahi is saying k-fold validation is used to evaluate the model using the training data set. If we have 100 rows of data, we can divide it into 5 equal folds. 1, 2, 3, 4, 5 in the first iteration. Fold 1, 2, 3, 4, 5 used for training, and fold 5 is used for validation. So this is the example of validation, right? And now let's say, okay, so the example that is given by Dhamini, it's the validation only. But I was asking, why do we need validation? And the example that is given by Dhimahi is used like you are just dividing the whole data set to different folds. Okay, k-fold cross validation data. Okay, so there what we do, we actually divide those 100 rows, means 100% data, to 20, 20, 20, 20, 20. You can divide it by 20, 20, sorry, 25, 25, 25, 25, whatever you want. Okay, and then what we do, okay, we actually train it on 80%. We actually take 4 chunks at a time. Fifth would be a, means 1, 2, 3, 4, 5 for training. 1, 2, 3, 4 for training. Fifth for testing. Then 1, 2, 3, 5 for training. Fourth for testing. 1, 2, 4, 5 for training. 3 for testing. 1, 3, 4, 3, 4, 5 for training. Second for testing. And then 2, 3, 4, 5 for training. 1 for testing. So this actually this is the example of k-fold cross validation that Dima is talking about. Okay, this is the type of validation technique. Okay, this is a type of validation technique. We do use k-fold validation only when we are not having enough data. Okay. Okay, so yeah, but I appreciate all of you. Like you guys are actually putting your own points as well. Raj as well. It has given some insights. Yeah. Yes, validation ensures high quality, reliable, and consistent data enters the training data. Yes. So validation is basically like practicing exam at home before giving final exam. Am I right? Uh, no, it's not the correct. I think the example. It's like it's like instead of getting trained with the whole book. Imagine you are giving your exams, and there might be so many examples that are there in already in the book. So instead of training you guys on all the examples, your professors might choose some of the examples to not just for training, and then other example they can use for testing. And after that testing, they will check your performance with the questions, and without actually telling you the questions, without actually making you guys appear in the exam. Before then only they can just simply take your test with the help of those examples only. So we are actually dividing the training data set also to two types, or to two parts. Training and validation, and then testing is already there, 20%. Yeah, Raj, exactly. Okay, I hope you got the point now. Now, training. Training. So training is, training well, then test and validate. Okay, test and validate, and then you deploy it. Simple, right? Now, there are types of regression. So the first is Simple linear regression. So generally, when you say simple linear regression, guys, can you tell me like what is the name of this particular equation? Can you see the equation right here? H of s is equal to beta beta naught plus beta 1x. Okay, y is equal to mx. Is it the form of equation? Are you sure, Darshan? Now Yuvraj Singh is saying slope equation. Are you sure, Yuvraj? Your name is correct. Raj, equation of slope like. What is slope equation? Motion equation. Linear equation. It is a linear equation. It can be seen. But what type of linear equation? Means what type of means which form? You are missing a word. You are missing a word. And that's why I'm too, worried about that word because that word is important. No, no. One variable, no binomial, no y is equal to mx. Yes, guys, it's not slope equation. It's slope intercept equation. It's a slope intercept form. Yes, Yuvraj. It's not slope form. It's slope intercept form. Slope form is the y is equal to mx. But it is y is equal to mx plus c. And if we are missing this intercept word means we are actually missing our bias, right? We are missing our bias. So, okay. So the simple linear equation, simple linear equation is something simple. One independent variable, one dependent variable. Simple. And then we simply put it on a simple Cartesian plane and then we simply check it. You know Cartesian plane, right? You know Cartesian plane? CARTESIAN, Cartesian plane. Okay. The XY plane. Okay. If you are unable to get it, this is what it is. Okay. So what you can see here right now, okay, what you can see here right now is nothing but it's a Cartesian plane where you can see different points, right? And your model is actually learning, and it is actually learning the path of the data points after every iteration. Okay, after every iteration, it is basically learning, and there are only two columns. First, your years of experience. The second is salary. Okay, second is salary. So, guys, but do you think that we only deal with the two columns, one dependent, one independent? No, right? Then do you think that we can use simple linear regression for our problems? No. Then what should we use? If y is equal to mx plus c, if h of s is equal to beta naught plus beta 1x is not our, is our cup of tea for 99.99% of the problems, then what should be the answer? Then what should be, we should do? Simple. What we should use? Guys? Okay, Vishwajit. If in linear regression there are only two columns, one is independent, one is dependent, but in real life scenario we can have a 10, 20 columns, then what should be the correct regression? Now I'm getting the answers from Sonu Yadav, from Rohan, from Vishwajit I got. What about others? I can see around 250 plus students. Why only few people are answering? Guys, I want answers. Decision tree? I'm not I'm saying about the regression only. I'm not talking about regression tree. Regression tree is okay, but yes, Jay, good one. So the answer is multiple linear regression. Okay. Yes, yes, Shesh. Answer is multiple linear regression. Right? So the multiple linear regression is something that actually take care of multiple features. Okay. And then it can actually show you, like as you can see on the graph, this is how actually it would be, it would look like when we'll plot this particular, model on graph. Right? Now there is a homework question. Homework question. Okay. Guys, can you see line in this? Can you see a line in this? That's why it is a simple linear regression. Relatable. But can you see a line here? Can you see a line here in multiple linear regression? If yes, then that is okay. The name is correct. If no, then why it is linear multiple linear equation? Why it is multiple linear regression? Is it a line? Is it a line? Yeah, it's a plane here instead of line. Yes, Aditya. That's why I'm saying if it is not a line, then why we are calling it multiple linear regression? It is multiple linear regression because of the degree of equation. Okay, because of the degree of equation. Can you see the degree? What is the degree? The highest power of the polynomial, right? No, the degree is not 3. Degree is not 3. Harsh, degree is 1. Can you see power just above this? No, right? No, right? Yeah, degree is 1. So this is the reason how multiple linear regression we used to use. We do use, okay? And now, and now there is one more thing that is that we have discussed in the last class that most of the time our graph would not be like this. Most of the time our graph would not be like this. It can be curvy, right? It can be curvy. Then how we will be able to utilize this linear regression? If your line is curvy, then your linear regression won't work, right? How will you result it? Polynomial regression. Okay? How will you resolve it? Yeah, okay, Vishwajit. So, polynomial regression. So, the polynomial regression is something that actually understand your different degrees. So, this is the reason of polynomial regression. Are you getting my point? Now, okay. So now let's start something, you know, practical. Okay. So now let me just stop sharing and let me just open my collab. Sahil, I'm basically I've done my master's in data science, artificial intelligence, and machine learning. Okay, and I was a silver medalist. I scored 94%. So yes, so I'm just sharing my the Google Colab, and there we go. So, like instead of actually typing it, each and every word, what I have done is, I have just created the, one file, okay, and because actually, if I'll just type and try to do it in front of you, what will happen is it will take a lot of time, okay, because we need to analyze the things, we need to uh, try to do different stuff. If you want me to create a simple, uh, can you share the collab? Yeah, sure, I'll share the collab. Don't worry. Okay, I share the link. Okay, so basically, right now, why I have done this thing instead of writing in front of you. The reason is like then in that case, most of the time will be utilized in while typing only. Okay, and now you can see a lot of different concept is there. Okay, this box cogs, Shapiro means some hypothesis testing are also there. Standardization, normalization is also there. Can you share the notebook so that we can along with you while understanding the code? No, uh, not right now. I'll share the collab after this session. I request everybody just look into the this interface because I will not actually explain you the concepts. Okay, sorry, explain you the code, but along with this, I want you to explain the concept as well. Okay, that how this is exactly standardization looks like, how this basically Lasso and Rich is different from linear regression, how this mean absolute error and mean squared error and R2 score, and what is variance and inflation factor. Okay, I want you to learn all these things. Okay, why we have used hypothesis testing. Do you guys know hypothesis testing? Do you guys know hypothesis testing? Yes. Why do we use hypothesis testing? Hmm? Why do we use hypothesis testing? To test a sample. Hmm. Okay. To check the normality, to check the interdependence, to check the correlation, lot of things. Okay. We do use hypothesis testing. Okay. So I just wanted you to actually the purpose is I want you to learn how actually working with models look like. So it's not like you are always, just type few little bit code and it will work. No, it will never happen. So now let's start. Okay. So we have imported all our necessary things. Okay. We have imported all these things. Okay. And then this is nothing but this is Jamboree admission. Okay. There's an exam called Jamboree. Okay. And in that exam, there are a lot of, different types of score and other things are, required. And then, along after submitting all these different scores, uh, you know, uh, then your selection of the process starts, and not still each and everybody get the selection. So the problem is instead of waiting for the outcomes, instead of waiting for the results, we can use this particular model. We can use this particular model, and we can actually predict that whether I will get selected or not. Okay. So I am having this small data set. Okay, this small data set only contains 500 rows. Okay, it's a really small data set, but we will cover most of the concepts. We can cover most of the concepts through data set. Okay, so first, so this is how the data set looks like. The first is serial number, second is GRE score, then TOEFL score, then university ranking, then SOP, LOR, CGPA, research. Okay, if he has done some research, then it's 1. If he has not done some research, then it's 0. Then there are chance of admit. Okay, chance of taking admission. So for us, we can simply notice this serial number is totally illogical, right? The serial number is totally illogical. So we can simply drop the serial number. We can simply drop the serial number, right? Yeah. Okay. So then after dropping it, this will be our final, the score. And yes, that how the score will looks like. So GRE score is out of 340. Okay. TOEFL is out of 120. University ranking out of 5. Statement of purpose out of 5. Letter recommendation out of 5. Undergraduate GPA is out of 10. Research experience either 0 or 1. If you have research experience, then it's once. Then it's 1. And if you are not having a research experience, then it's 0. Then chances of admit is 0 to 1. Multiply by 100 means 0 to 90, 0 to 100%. Okay, so this is how our data looks like. Okay. So now let's understand the this part, this info part, right? Let's understand this info part now. So okay, so what you can see, there are no null values. All the values are perfect, so no data cleaning is required. No need to waste time on data cleaning. So now this is our describe. Guys, what insights can you give from this description? Can you give me any insights on this? You don't just tell me the numbers. So this is this is the count, this is this. Tell me proper insights. What you can get. Anything that is relevant for my model that I needed to learn. Just data is right in front of you. Tell me what can be learned from this whole thing. I want inputs, guys. Data. Can you see the screen, right? You can see the data, right? You can see the data. Please give me the inputs. Who is the topper? Who will score more good? Overall good. What are the max and min values in our data frame and what is statistical analysis? No, no, no. I'm not saying like what you can see. I'm saying give me the insights, understand the description, and then give me the insights. What is the statistical measure of the data? Okay, the statistical measure of the data You are not understanding the question. TOEFL is score is based on university ranking. Variance of DRE score is more large in now you guys are giving some technical answers. Variance in DRE score is large compared to TOEFL score. Okay. Here, not an entry in chance of selection. Nothing like that. From min value 25% the answer, max value the 25 70% is the answer. Both the answer not too big, so I think the anomaly are less. Just assumptions I think like yes. Thank you, Tejas. This is what I wanted. This is what I wanted. There are no big anomalies. Are you getting my point now? Okay. Can you tell me something about this? You know, this research. This research. Don't you think कि only 56% around 56% of the people like they are having this research? Only half the population is having research. Means this will not be a really good factor of deciding our chance of admission. So since we are only having few features, so we there is no need to drop it. But if we had lot more features, we could have just simply drop this. Mean CGPA can be used to select the students. Okay. Okay. So now, can you see one more thing? Can you see one more thing? So the mean of getting a chance is 72%, right? Mean of getting a chance is 72%. Means average is 72%. So what do we mean by this? Generally, in every candidate's Python file, I used to see this kind of description, but I have never seen someone, actually identifying some really good insights from this. But this is actually something really important. Okay. Okay. So we have already checked that it's null free data. Okay. The shape is 500 cross 8. Okay. Then df dot duplicated. There are no duplicates. Yes. Can you tell me what is it? Can you tell me what is it? And what is it? What it is actually defining? Yeah, it is heat map, but what actually heat map defines? What does heat map defines? It actually tells you about correlation or collinearity. Does it tell you about correlation or it tells you about collinearity? What is the difference? Everyone. What is the difference between correlation and collinearity? You know collinear, right? What is the difference between correlation and collinearity? Guys, you guys are taking too much time. You need to understand a lot more concepts right now. No? Okay. So now let me explain you that. Just a second. I think I need to open some whiteboard. Mm, 1 minute. Just a second. I'm just opening this new file. Uh, okay. So let me share this. Okay. So, guys, correlation matrices when just imagine you write x1 equals to 3 times x2. This is your correlation is. Okay? This is your correlation is. Okay? Now, collinearity. What is collinearity? Collinearity means, can you tell me what is collinearity before I answer? Okay, Viral is saying collinearity means there are two or more independent variables that are highly correlated with each other, creating unreliable model coefficients. Okay. Percentage of data similar in both features? No. Y is equal to 2x, something like that. वो तो that is correlation है, Parth. I am asking about collinearity. Near relation between different variables. Chirag, two or more independent variables are involved. Okay. Yes, correct. So if I'll write the equation here like this, y is equal to, not like this, x1 equals to 2x2 plus x3 plus 4x4 this is how collinearity looks like, right? Multicollinearity, basically, multicollinearity. This is the example of multicollinearity. Okay, perfect. I hope you got the point right. Good. Now, now, so now let's come back to the point. So now this GRE score. So I am right. Yes, you are right. Okay, good. So, okay, so this is how correlation matrix look like. Can you see this df.core? This df.core means correlation. Okay, this is the data frame and this is correlation. And n0 is equal to true means these numbers. Okay, so this is how heat map looks like. And the darker the region, the more collinearity, oh, sorry, opposite I'm saying, the vice versa. So lighter the region, more the collinearity. Okay, lighter the region, the more collinearity. Darker the region, less collinearity. Not collinearity, correlation. So sorry, guys. So sorry. So darker the region, less correlation. Lighter the region, high correlation. Okay. Okay, and there is not as such correlation. Almost, it is almost the maximum is one only. Okay, and maximum is one. Maximum is one means why? Acha, okay, can you tell me why this is one? Why all the diagonal values are one? Why all the diagonal values are one? It's a simple answer. Okay, so teacher is saying, sir, what you have said collinearity in linear relation between two variables. That is correlation. If two variables are involved, we say it correlation. But multicollinearity involves multiple variables. Okay. Yes, Harsh. So this is because if you have noticed why this is one. This is one because here is also GRE score and here is also GRE score. For GRE score with GRE score is one only, right? What do we mean by one? One means if your correlation is tends to one, this means that it is highly correlated, and every variable is highly correlated with itself, right? With self correlation means if I am increasing, I am increasing. If I am decreasing, I am decreasing. Okay, so that's why all the diagonal values are one. Okay, few of the people they ask me why all the diagonal values are one. Okay, sir, then what is covariance? Okay, we'll talk about covariance as well. Okay, we'll talk about covariance. Okay, let me write it somewhere so that I do remember that. So now, okay, so this is what it is. Okay, covariance and correlation are something same. No, not exactly. Okay, covariance is something, yes, means when you will just look into it superficially, you will understand that actually they seems like they are same, because covariance is also the spread of one feature, how it is impacting the spread of other feature, right? Like it actually measures how two variables are moving together. Okay, okay, like if one increases, second increases. If one increases, other decreases, or no relation, right? So this is covariance. But the correlation is, it is, basically you are uh, shrinking it to a particular range. Okay, you are shrinking it to a particular range. Okay, so correlation is mainly, it can be negative, it can be positive. Okay, it can be negative, it can be positive. If one is increasing, second is increasing. What is one is increasing, second is decreasing. So correlation is basically, it is well defined in range. So this is the basic difference. Okay. Okay. So covariance is basically, it is it is same, but it is different. Basically it is correlation is something, when you standardize it between a normal range, you are just standardizing in a particular range of -1 to 1. This is correlation. Okay. Nice. Thank you for asking this here. Who asked this? Tejas. Thank you. Okay, now let's. Can you tell me what we are doing here? It is simple. Can you tell me what we are doing here? Can you understand the code? This code. What we are doing here? No. It's okay. It's okay. So basically, what we are doing is we are creating bins. Okay, we are creating bins to better understand the scenario. We are creating simply bins. So can you see this now? We have created just GRE score bins. So in which category this GRE score is coming? So this is 337 category. So the bin is 332 for 340. The GRE score is 324. So the bin is 320 to 330. So we have just created the bins. Okay, we have just created the bins. So you can see the function is fi plus fi plus 10. Okay, so whatever the range is, we are just adding 10, nothing more than that. Okay, we are just creating bins. Okay, so to basically to better understand the scenario. Okay, how the distribution is, the how well the data is distributed in other different categories. So you can see most of the people, they belongs to some high score, some high GLE score wins. Okay, this means that most of the people, they are, uh, actually getting really nice score between 310 to 330. Almost more than half, almost 300 people approximately, they belongs to 310 to 330. In this 20 numbers, in this gap of 300 310 to 330, this 20 numbers, this is 300 belongs to 300 people belongs to this particular group. Okay, so means before training, we are actually trying to understand the data, and then after that, we did the same thing for TOEFL score as well. Okay, so what actually is happening? TOEFL score is out of, I think, 120. So the data is distributed among something like this. Okay, most of the people, they belongs to above 100. So I think we are having the data of toppers, if I'm not wrong. We are having the data of toppers. Most of the people, they are, above 100, right? Then again, we are actually creating bins of TOEFL score. We are creating bins for CGPA. Okay, we are creating bins for, chance of admit. Okay, and then we are then understanding like how many people are actually belongs to which category. So most of the people, like they are getting 0.7 to 0.8, means 145 out of 500. 145 people belongs to 0.7 to 0.8, and from 0.6 to 0.8 there are above 250 people. So half of the population belongs to 0.6 to 0.8. Half of the population, 0.6 to 0.8. Okay. This actually tells something about the distribution of the data, how data is well distributed. Okay. Then same is with this. Okay. Nice. Now let us check the distribution one by one. So this is distribution. So you can see the GRE score, the maximum count is coming from 320 to 330, 149, 149. Then TOEFL score range, the most of the people, like above 50% people belongs to 100 and 110. Okay. And if I say 100 and 120, means only 20 people, they are having, uh, approximately 350, 450 approximately. Then we are having university ratings. Okay. So this is the university rating. And then uh, most of the university are belonging to rating third. Okay. Means most of the university has given third rating to the people. And then research, not a big gap, not a big gap. I think only one per. Okay, so only 54, 55% people are having research, and 45%, 40% or 50% are people having not research. Okay. Then statement of purpose. So this is somewhat not that, uh, yeah, it is, I think it is okay, not much gap. Here also we cannot see a much gap of letter of recommendation. Almost everybody is having the letter of recommendation, and rating as well. So out of five, most of the people are getting, rated between 3 to 4 only. 3 to 4 means 3 to 4.5. Okay, 3 to 4.5. It's good. And then undergraduate GPA, okay, most of the people are, around 300 people. They are getting 8 to 9 GPA, and then there is chance of admission. Okay, so now we have understood that there are only few things that can decide your factor. So research is not something that can decide a factor. TOEFL score can decide, GRE score can decide, university rating can decide. Okay, yeah, GPA score wins decide, right? And COA wins also, we can say, you can decide. Okay, so these are the top three variables that will basically decide our score: GRE, TOEFL, and GPA. Okay, yeah, university rating as well. Okay, so this is what we have understood. Now let's check about the outliers. Okay, so now can you tell me what are outliers? Can you tell me about outliers? What are outliers? Okay, so binge equals to range, like it's a part of the data segmentation process for the making data feasible for model training. But one question, sir, how is this range data used in ML? Like, would it learn the approx range by the independent variables? Like, it won't learn. Even I have not given any. Okay, Raj. Right now, we are just trying to understand the data. We have not started building the model right now. Okay. We will do it later. Later means like in upcoming code snippets. Okay. Right now, we are just trying to understand the data. We will not use this kind of bins in our model training. Okay.
Okay.
Uh, okay. Outlier is data point which reside far beyond data group. Okay. Whose value is abnormal. Support data that not fit in actual data part. Okay, Sahil. Okay, Raj. Okay, Sujal. Okay, Aditya. Yuvraj. Parth. Shlok. Okay, Shlok is saying something. Data points which are outside the specific range of data we can identify outlier. Okay.
Listen.
Hmm.
Listen.
Hmm. Okay, Vedant. Yes. Okay. Good one. So now let's check for outliers. So can you guys tell me something about outliers using this data dot description? Can you tell me the definition of outliers mathematically? Can you tell me the definition mathematically of outliers? What is the range of outliers? Accepted range. IQR. What is IQR? What is IQR? Hmm? No? Interquartile range. Interquartile range means what? No? Okay. So what is IQR? The full form of IQR is interquartile range. Okay. What is this interquartile range? Interquartile range means, okay, interquartile range means there is a first range is that is 25%. Then 50%.
हो सेंड करते हैं ना
Then 75%.
हो दो हो सेंड करते
Is it the interquartile range?
हैं
Is it the interquartile range, guys?
हाँ
Am I correct or not? Is it the interquartile range? Anything above this? Anything below this? Oh, vice versa. Anything below this, below 25%, or anything above 75%. Am I correct? Or something else? What is IQR? Everyone. You guys have studied all these things. I think you told me in the last session, sir. We have already studied all these things, right? So that's why I'm asking questions. IQR is spread of atom. I am asking whether this is okay or not. Whether this is okay or not. Okay. Are you sure? No, this is not okay. For the people, those who are saying this is okay, no, this is not okay. Okay. Not okay.
माझ्यासाठी बिलकुल ठीक आहे.
Outlier rule is outlier. Where is outlier? Huh. Outlier rule is this is your quartile 1. Okay.
त्याला लोकांची नाही आहे मला.
Okay. This is your quartile 2. This is your quartile 2. And this is your quartile 3.
हो, बोट जेव्हा सर्टिफिकेट जनरेट करायचं ना.
Okay.
बरोबर आहे.
So now so this is IQR. But this is IQR. I agree. But does not define your this does not define your box plot. This does not define your range. What is the range? The range is above Q3 plus 1.5 times of IQR. This is your upper bound. And if you will simply minus Q1 minus 1.5 of IQR. This is your, now this is the range. This is the range. Let me change the, like, okay. Now this is the range. Now anything below this part and anything above this part is outlier. This is the standard practice that we use 1.5, but it is not fixed. But it's a standard practice, so most of the times we use 1.5 only. So you can say it is fixed, but yeah, it's up to you. If you want to change the formula for some reason, you can change it. But most of the time, generally it is the industry accepted number 1.5. I hope now you have understood this thing. You understood the outlier concept, no? You have understood the outlier concept, right? Any challenge? Everyone? There are above 250 students. Guys, any challenge? There are about 250 students. So that's why when I asked you about, like, can you give me some insights on this? So this was the reason. See, 25 percentile, 57 percentile. So Q1, Q2, Q3 are already given. Okay. See, guys, this is your box plot. So this is your Q1, Q2, Q3. Okay. Okay. Vice versa. Q1, Q2, Q3, and above Q3 plus 1.5 IQR. Upper bound. Lower bound is Q1 minus 1.5 into IQR. Okay. And you can see there are no outliers. There is only one outlier that is also for chance of admit. Otherwise, and yes, one for LOR as well. Okay. Otherwise, not as such outliers. Okay. Then let's start something for machine learning now. Let's start something on machine learning. We have understood the data and everything. So now this is how we have again, imported the data because we have already, created the pins in the previous data. So we have again imported the data. Then we have, dropped the serial number because it is of no use. And then we have started, doing our machine learning part. So this is what we have done. We have splitted the data. Okay. We have splitted the training data. Oh, sorry, not training data. We have splitted the dependent variables and independent variables. So all these X values are independent variable and Y is the ground truth. Y is the label. Okay. So chance of admit is what it is label, and X contains all the columns apart from chance of admit. Okay. And then simple
એટલે મેં
print
એમ
as
કહેતો હતો
split.
કે આ જે CSV ફાઇલ
So
છે જેના ઓપરેશન કર્યા કરે
X is what?
તે આપતા છે કાંઈ
Your independent variables. Y is the ground truth, and how much we are splitting by 0.2. Test size is 0.2, and random state is 2. Random state is just a seeding. Okay. Now, can you see this standard scalar? Can you tell me what is this standard scalar? Can you tell me what is the standard scalar?
પણ પાછી પેલી CSV ફાઇલ રહી તેનું આપણે લોકેશન આપવા જ પડે છે એક્સેસ કરવા માટે.
Okay, explain, repeat X and Y. X and Y is nothing but I have, okay, so what we do is, so what do? We actually split the data, right? So this is the data. Okay, this is the data. And now what you are doing is you are just splitting the ground truth. That is Y. What is it? It is Y. And you are splitting these two things, X and Y.
હા,
Okay.
હાલો હવે.
So this is what we are doing here. Okay. Now, can you tell me this? What is the standard scalar? The standard scalar is standard scalar is yes. Okay. So what it does is, so what is the formula for standard scalar?
ભગાવ નહીં કરે.
What is the formula for standard
બધાને
scalar?
તમારું group છે. ના આ તો પેલું થયું સ્ક્રીન એક્ઝિટ થઈ જશે.
So second.
મને આવું જ લાગે પેલું માથામાં કેમેરા માથું મારી ગયો હતું.
Just a second.
વેબકેમ છે તને?
What is the formula for standard scalar? Do you know Z score? Do you know Z score? Standard scalar is Standard scalar is, okay, when your data is between 0 and 1. Okay. Okay.
डिस्प्ले में क्या है?
When your data is between 0 and 1. 0 is mean. Okay. And standard deviation is 1. Means your data will lie between 0 and 1.
ओके ऑफलाइन जो है ना ऑफलाइन
Okay. Right? You got the point, right? Okay. And then second is min max scalar. Means min max normalization. Okay. So this is how it works. Okay. So this is how it works.
એઆઈ નું એક જ છે
Okay.
મને નહીં ખબર પણ
So this
પેલા
is the
apply
formula.
કરતો ને ત્યારે મેં જોયું
Okay. Oh, where is the collab file?
મેં બહુ બધું છે
Oh,
લોકોનું
I
જોયું.
removed the collab file. Just a second.
NJ fold.
Just a second. Oh, reopening it.
કઈ કનેક્ટ થઈ ગયેલું છે ને TWS મારામાં કાં આવ્યા કરે છે કોનું અંડર અંડર મેન્ટેનન્સ માં છે
Okay. Sure. Okay. So this is how it's look like. Okay. So we have done this standard scaling. Then we scaled our training data. We have scaled our test data. Okay. And then we actually tried to fit sm.ols ordinary least squaring method. Okay. Ordinary leads. Okay. This sm.ols is nothing but it's a ordinary least squaring method. Okay. So it is used for linear regression only. It is used to fit the model for linear regression. Okay. Okay. Now you might ask like what is this? So for now you can just ignore this. If you want to know what is it, we are just saving the model. Okay, so that we can utilize it for our web page development. Okay. If you want to utilize it to create a web page or you want to create a proper full fledged project, so we use this pickle file. Okay. Right now you can just ignore it. And now if you want to check the model summary, like what is the accuracy of a model, so model or summary, so this is the model.
આર્ટિફિશિયલ ઇન્ટેલિજન્સ ડેવઓપ્સ પછી આ
Okay.
બાજુ એન્ડ્રોઇડ કોણ છે
So this is the model summary. Not much into it. Okay, but you can see this is the F statistic. Check this R square method.
બીજા તાન કઈ ગયેલા
This is the R square
અહીંયા પેલા
evaluation.
ઇન્ટરશીપ કરે
Okay, this is also called R2 evaluation. Okay. Okay. R2 score is nothing but it is used to evaluate the linear. It is used to evaluate the your model. Okay, especially your regression model. Okay.
કેવું મુશ્કેલ છે
If you want to learn the formula, I can tell you the formula as well. If you want to learn the formula,
એ પેલા 18 મંથમાં 50,000
you can just. Okay, so this is how it look like. See, this is what we have predicted for our X test. Okay, so this is what we have predicted. Okay, we try to predict, and now we are training with the linear regression. So we are getting approximately 80% of the accuracy. Okay, so do remember this OLS method, sm.ols. This is used for statistical analysis. Means generally, if you want to just look into like how it is getting trained and all, it is nothing but people use it for linear regression. It's not a you know different thing that we are doing. OLS is the ordinary least squaring method, is nothing but it's a linear regression only. Okay, and here also it is linear regression only. But if you want to use for just model scaling and all, generally people use this library, this module, linear regression. Okay, so we are getting it 80% of the accuracy approximately. Okay, so now uh, hmm, okay, so you can ignore this part for now. Yeah, now this is something that is homoscedasticity. Okay, homoscedasticity. Now what is homoscedasticity? Let me show you what is homoscedasticity. Homoscedasticity is now I know this name is homoscedasticity is when your data, okay, when your data is in a particular sequence, then this is homoscedasticity. But when your data is spreaded,
variance of the error, error, a level of the independent
something like
variable.
this is heteroscedasticity. Heteroscedasticity. Okay, so this is not we wanted. Okay, we want this. Okay, homoscedasticity in a line, in a sequence. Okay, so to test the homoscedasticity we have
तो करनी
this. Okay,
email कर
so we can simply check
email कर
whether our data is
हाँ कर
homoscedastic
बना
or heteroscedastic. So you can see the model is it has some outliers related to homoscedasticity, but more or less it has most of the data points are range in between -1 point 1 to
तो
plus
लगता
point
है
1
नहीं तो
only.
लगता है
Okay,
हाँ
so it
तक ही
is
आ गई
homoscedastic only, not a big deal. Okay, and yes, we are also checking for checking for the predicted values for train.
27
These are the predicted values for train, and these are the predicted
7
values for test. So we need to understand that whether our test data that we have provided, does it follows the same distribution, or it is the or whether the test data is more heteroscedastic, and our training data is homoscedastic. So to check the distribution, this is also important. And now we can simply evaluate our model. So our mean absolute error is, it's 40, so
billion में
it's
correct
0.04. Okay. Root mean square
यार
error is
बिजली का
0.06.
क्या लगता
R2 score is good, approximately
बिलियन में लगता
80%, and adjusted R2 score is
काफी गेम के लिए
77%. So it is more or less a balanced
बात
model.
नहीं
We
करता
can
मेरे
still improve it. Okay. And then comes lasso and rich regularization comparison. What are these lasso and rich regularization
इवेल
comparison? What is this lasso and rich?
इवेल
Okay.
इवेल
So
इवेल
lasso
नहीं
and
लगता
rich, they are
इवेल
nothing but they are used to actually calculate.
क्लास
Sorry, yeah, sorry. They are used to actually to resolve the problem
Low
of
pin service.
overfitting and underfitting. Okay, lasso and reach, they are used for to resolve the problem of overfitting and underfitting. Okay, now what is lasso and what is reached? What is lasso
नेमे वीडियो रखे
and what is? Do you know this concept, lasso and reached?
एक और जब
Do you know this concept, lasso and reached? No? Okay, no worries, no worries. Let me tell you. Don't worry. So, guys, just a second. So, lasso and reached. If you don't know, it's okay. Okay. This, if you know something about loss function, then you will be able to understand what is lasso and what is reached. Okay. Then you will be able to understand. Okay. So basically, lasso and reached is nothing but it actually helps you to train your data and for the overfitting and underfitting type of problems. Okay. So you generally say it L2 regularization or L1 regularization. Okay. This is what lasso and reach all about. Okay. So don't worry. Let me actually tell you the formula. Okay. So what is lasso? Lasso actually tries to take your model to underfit. Okay. Rich is something that tries to make your model overfit. But now you will ask, sir, why do we need to basically make our model underfit or overfit? We don't want either, right? Okay. It basically, we don't want either underfit or overfit. But when we actually are facing underfitting problem, then this is a requirement that we pull our model to overfit. Means we don't want to make it overfit. We just want to make it in at least learn something. So if our model is too underfit, okay, then what we want is we want to make our model learn little bit. So we try to overfit that. Okay. Okay. If you're not getting something, if you're not getting something, uh, it's okay. Okay, we'll discuss this point in the next half. What is exactly lasso and reach, along with the classification. Okay, along with the classification as okay. So right now, if you are having any sort of doubts, you can ask me. Okay. So what we have understood till now. Okay, don't worry. Yeah, yeah. Actually, underfit and overfit you neutralizes each other. Okay, so don't worry. Just let's wait for 1 hour. Okay, in the next hour, after next hour, we will discuss about lasso and reach. Then we'll discuss about some, some discussion on the next half as well of classification. Okay, simple. Yes, you will get the qualify file. Don't worry. By the end of the second half, there are, both the qualify file you will get. Don't worry. Okay. Okay. Till now, if you are having having any sort of doubt or challenge, please let me know.
Strong.
Any challenge, everyone. Okay. So what we have understood till now is we have understood the type of regression is polynomial regression. We have understood the multiple linear regression. We have understood like what is actually simple regression. Okay, then we have understood the proper workflow. We tried to understand the use of validation data set. Okay, how we train it. Okay, and how we collect the data set. Okay, and then we have understood and we tried to understand uh, what is the need of evaluating the training and test data set, and why do we compare it. Okay, and we have understood like how differently the regression classification problems look like when it comes to the output. So classifications look like in the categorical form, and regression looks like in a numerical form. The output is okay. So this is what we have understood till now. Any challenges, guys? Any challenges? Any challenges, everyone? Vansh, no sir. Okay, good. What about the others? Any challenges?
તો આટલું ક્યાં થયું? મેં તો પેલું નહીં થયું થઈ ગયો.
Just now we have done the recap, guys.
તૂટી નહીં જાય.
Okay, so do we gonna do hands-on on later session? Yeah, in later session, in the second half also,
એટલે
you are having some
હવે
Google collab also.
ઉપર
Okay,
થાય પણ નીચે
okay.
આટલું બધું નહીં થાય.
Most of the stuff will be around Google Colab only. Why I have taken this Google Colab? Because most of the concepts are covered in that Google Colab only. See, ये homoscedasticity, heteroscedasticity,
આવું આવી જાય.
standardization, lasso and ridged, right? And then DCL3 is also coming. So
એ
most
flexibility
of the
પેલું
things
છે.
are there in Google Colab only. So instead of
હા,
just
પપ્પા
reading
કહેતા
out the
પેલી વાત.
PPT, let's go through the code only, right?
એ બે માં બે.
Yeah. Is there any lecture on data extraction like data scrapping? Scrapping? Mm, no. Well, like data scrapping comes under the data, initial phase only. So if they have taken, like I don't know, like I'm not sure. Uh, I will be only taking today's session. So
તેનામાં
in
કઈ
the, I hope you are having the schedule and the
હા
proper
સ્પેસ લેમ.
timetable, like what sort of topics we are covering. So yeah, in attendance you will get in second half.
લેમ પર
Okay.
તો
How
આવ્યો.
to how do we calculate outliers using IQR? Yeah, sure. So I already told you about this here, right? So what do we do?
ડિલીટ
First
કરો.
we calculate.
પ્રોજેક્ટ.
What do we do? First we calculate our
હા હા.
Q1. Okay. That is 25%. Okay. Then 50%.
મારામાં હા એ તો ક્યાં ગયું સ્ટોરેજ એટલે પેલું યાદ જ
Q2.
નહીં આવે એમ એ ભરે
Okay.
ચાલ્યા કરે
Then 75% Q3. Okay.
પણ તેમાં તો પેલી ગેમમાં ચાલી જશે આરામ
Then what do? You do
જીટીએસ તમે એમ જોઈ
calculate IQR.
ચાલી આરામથી હમ
Q3 minus Q1.
જીટીએસ 6 ને કે તમે એમ જોઈ જશે
Okay. Then this range will come. Okay. Means basically you are subtracting 75 minus 25. So this range will come, right?
ચાલુ યાર
Right? Right?
તો પછી
So now
કરવાનું
you will
એવા ચાલતું
subtract,
નથી પણ કઈ તો
you will subtract and find this range. And what is this? Upper bound. UB. Upper bound. What is this upper limit? Upper limit is Q. Oh, sorry. Lower limit, not upper limit. This is lower limit. Lower bound. So Q1 minus
આઈડિયા શું આવી ગયો
1.5 of IQR. Okay, and this, okay, upper bound is just opposite.
એટલે GTA
Upper
5
bound is Q3 plus 1.5
હા બહુ મજા
of
અલગ અલગ પ્રમાણે માઇક્રોફોન તો હજુ મજા
IQR.
ઓ ભાઈ આપણી મજા ઓપન વર્લ્ડ ગેમ ગઈ એટલે
Okay,
જે આપણે કરવાનું તે કરીએ એમ સચિન
okay. So this, so anything, so anything below this,
સાચે નહીં સમજ જ નહીં પડે
so anything below this is outlier, and anything beyond this, yani ki anything above this is outlier. Okay, I hope you understood. Okay, so okay guys, see you in the next half. Thank you.